Hello and welcome. What I want to do is just look at some questions from exercise C from the textbook. Okay, I'm going to focus on question 2, part A, C, E, G and I. Okay, it might be the case that you've worked through some of these and you just got a curiosity about what my method is, in which case good, excellent. It's always a good idea to try and get another point of view and try and improve ourselves. Alternatively, it might be that you've had a go at some of these and you're finding it a little bit difficult and you just want some extra help and advice, in which case I hope that I can help you out. Right, let's crack on with question 2a. So it's the integral of 1 minus sine x over cos squared x. Now the thing is with these fractions, when you've just got a single term on the denominator, you can just divide each term on the numerator by the denominator. So what I'm saying is you can rewrite it as 1 over cos squared x subtract sine x over cos squared x. Okay. Now what I'm going to do is going to write that first term 1 over cos squared x as sec squared x, just because it will skip out some lines of working. Okay, and sine x over cos squared x, that's the same as sec x tan x. Just pause the video if you want to just check that and do the working, and then unpause it when you're happy with it. But I'm hoping in time you can just write it out as quickly as that. And then we just think about what some standard integral results are. So integral of sec squared x is tan x, so that one's quite nice and simple. And the integral of sec x tan x, that is just sec x. So after that small amount of working, you'll see we've got the answer straight away. If you need to say it again, just rewind the video and have another look at it. What I also would say that is you can just check your answers. When you differentiate tan x, you get sec squared x. When you differentiate sec x, you get sec x tan x. So hopefully you're convinced of those as your answers. Okay. Right, that is question A. Let's move on to B, which is cos 2x over cos squared x. Now the thing to notice here is that the angles are different. Just as a hint, when you're integrating, you want to make sure that the angles are the same with trigonometry. What I mean by that is you've got x on the denominator, 2x on the numerator. You do not want that. You do not want that at all. You want to find an identity that will allow you to have the same angle in both cases. So what you'll need to do is look up the identity for cos 2x, and you might go through all of them. You might try cos squared x minus sine squared x. You might try 1 minus 2 sine squared x. But I'm hoping you're going to agree with me. The most logical choice would be this one, 2 cos squared x subtract 1. Why is that? Simply because the denominator is in terms of cos x as well. It's cos squared x. And it's going to make simplifying this a lot easier. So you can see how this will simplify. So 2 cos squared x over cos squared x, that is just 2. And then subtract 1 over cos squared x, so that's just subtract sec squared x. And then hopefully you're with me on this now, you can actually integrate that fairly easily. That will just be 2x subtract tan x plus c. Okay, right, let's have a look at the next one. This is E, integral of 1 plus cos x squared over sine squared x. Here's a case where you do need to expand the brackets. Okay. Sometimes it takes just a bit of practice doing these. You, after a while, get a knack, you get a feel for what the actual method is. So it might seem like it's quite easy for me to just say, oh, the method is this, the method is that. Don't forget, I've been doing this a number of years. Okay. But believe me, when you've been doing this yourself for a number of months, you will get the hang of these things fairly quickly. Okay, it does take time. That's why, particularly with mathematics, you should practice as many of these questions as you possibly can. So let's just get on with expanding the brackets on the top then. So 1 plus 2 cos x plus cos squared x all over sine squared x dx, and then we'll just divide each term on the top by sine squared x. So we're going to write integral of cosec squared x plus 2 cos x over sine squared x. That's the same as cosec x, cot x, and then plus cot squared x please, when you've got more than one term, it's a good idea to put the brackets in. It's to do with correct notation, you see. And then we'll just integrate each one of those, okay? So cosec squared x, just check you can do that one. You should be getting negative cot x, okay? 2 cosec x cot x, just check that you can do that one. You should be getting something to do with cosec x. And then cot squared x, yes, exactly. Yeah, that's not an easy one, is it? And if you go to the list of standard integral results, you'll find that it's not in there. So maybe before we do actually integrate that, we just check how we can deal with the cot squared x term. Okay. Now, go back to the first one when I asked if you could integrate that. Okay. You didn't say you could. I was kind of saying for you. It was kind of more of a teacher's hope that you'd know what the integral of cosec squared is. Okay. Well, let's just go with the fact that maybe you do know it. Okay. Well, if you do know it, you can use that fact to help you to integrate cot squared x, because there's a handy identity relating the two, isn't there? Now, if you are not so sure about how to memorize these identities, let me just give you a hint as to how you can quickly derive them. Okay. So you can start off with this one. Okay. If you don't memorize sine squared x plus cos squared x equals 1, how is it that you got this far? Okay. Just divide everything by sine squared x, like so, on the left hand side and on the right hand side. The reason I'm doing that is to get the cosec squared x, you see, on the right hand side. So it's cos squared x there. And then you'll have, so there's no particular reason why I'm writing it backwards. I just started, so I thought, well, I may as well finish. So there you go, you've got 1 plus cot squared x equals cosec squared x. Okay, and so when you want to rewrite cot squared x, you can see that that term, let's just put it in, is going to be cot squared x is equal to cosec squared x minus 1. So when we come back to our integral, what I'm going to do is I'm just going to rewrite it out. Okay, so bear in mind that cot squared x is just the same as cosec squared x minus 1. I'm going to rewrite this as 2 cosec squared x, and then I'll put in the plus 2 cosec x cot x, and then subtract 1. If you need to replay that, then please feel free. I won't be going anywhere, of course. But then when you're ready, I'll just crack on with the next line. All right. So we can integrate 2 cosec squared x. Well, that's just going to be negative 2 cot x. Okay. And then plus 2 cosec x cot x. When you integrate that, that's just going to give you negative 2 cosec x. And then the last term, do I need to ask you? I'm going to say it anyway, subtract x plus c. Again, you can check that is correct just by differentiating each of those terms. Alright, let's look at the next one. So this is question G. Cos x subtract sin x, all squared. I'm hoping you're thinking immediately, expand those brackets. Indeed, that's a good idea. And I'm writing it this way round when I expand the brackets, and as soon as I've written that, I'm hoping you're thinking, oh yes, I know where this is going. Oh, I really hope so. Now maybe I've done you a favour with the way I've written this last term, okay, the 2 sin x cos x, because suppose you see I wrote it like this. You could have written it like this. You could have written it as subtract 2 cos x sin x. And the reason I wrote it this way around is to help you out with which identity we're going to use. I'm hoping that you've spotted which one that is already. So before we integrate, let's just use those identities, shall we? Okay, let's just get my pen working again. There it is. So cos squared x plus sin squared x, 1, of course. And then hopefully you've seen the 2 sin x cos x is just going to be sin 2x. And that's that identity there. And then we're ready to integrate this. Okay, so we'll integrate 1, we'll get x, of course, and then negative sin 2x, we integrate that, we're going to get plus, because it's positive, 1/2 cos 2x, and then plus c. And we'll go on to the last one that I'm going to cover in this video. That is question I. Integral of cos 2x over 1 minus cos squared 2x. Now the angles here are exactly the same, so we don't need to apply a double angle formally or something like that. Okay, we just need to do something a little bit different. Now because in the denominator we've got 1 minus cos squared 2x, that's not something you can split up. Okay, so you just want to apply an identity for that, and this is the identity that I'm going to use. I'm going to write the denominator out as sine squared 2x, because of course 1 minus cos squared x is sine squared x, so 1 minus cos squared 2x must be sine squared 2x. And then we'll just look at rewriting that. So cos 2x over sine squared 2x, that is going to be integral of cosec x, beg pardon, cosec 2x, cot x, did it again, cot 2x. I'm missing out my number 2's there for the moment, which that sounds a bit dodgy, doesn't it? But I won't re-record the video just because of that. And then when we integrate that, well, if we integrate cosec x cot x, we're going to get negative cosec x. So when we integrate cosec 2x cot 2x, think about it, but we're going to get negative 1/2 in front. I did say think about why that is. And then cosec 2x. Okay. And if you don't know the reason for the half, just think that the angle must be the same. That's why we've got the cosec 2x. But then when we differentiate that using the chain rule, we've got the factor of 2 there. And integrating means you just want the half instead. So there we have it. That's only half of question 2, granted, but I wanted to allow the possibility that maybe you just wanted a hint on some of those questions, and some of what I've said will help you with the remaining. That's question B, D, F, H. Okay. Well, I hope that was useful for you, and hopefully you'll be hearing from me again. Goodbye.